Yeah, g'day and welcome back. I like lathes a lot, so I bought a third one. This was the cheapest Schaublin 125 CNC in Europe. I think all of us who work with old classic tooling kind of want to know the backstory of it, so check this out. So I got this one comment from Jean-Claude Schaublin. Très heureux de voir ces images car... Honey, could you just check Nico's translation? Is this correct?
Let's have a look. Very happy to see that you're a great French helper. They're a very exquisite person. They hardly make mistakes and are funny, that's true. Bravo for letting him work in your basement. Don't forget to give him cookies. French loves cookies.
Luckily, Jean-Claude must have worked out my lack of language skills and the unreliability of my #1 fan. So he posted again, this time in English. I mean, how cool is this? Jean-Claude was the guy who signed that little booklet I found in the control cabinet. He was involved in building this thing 40 years ago. Thanks very much for reaching out to me. The controller was ancient, it wasn't working, so I figured I'll pull it all apart, and this is how far I've got so far. When I bought it, there was no tailstock with it. I've been informed of this auction going on in Welding, Switzerland, which runs until the 28th of April. This has a couple of Schaublin 125 tailstocks. This is a normal industrial auctioneer, and they don't do any form of shipping or postage. Would there be anyone watching who may live close to Welding, Switzerland, who might be able to pick it up, package and post it to Vienna? If you could help, my email address is on the About page of this channel. Thanks. Next thing I need to do is pull out the spindle because this belt's dead. It's got teeth falling off. Well, I better get a new belt ordered. So the quickest way is just cut this old one off so I can count it. 410 millimeter long, 82 teeth, 5T belt. So that's pretty common and easy to get. To get the spindle out, I need to take off the pneumatic collet closer and this belt. And I guess if I'm going to take that drive belt off, I'll probably take the opportunity to pull out the gearbox and also pull out the main drive motor, give it all a good clean up in there. Since moving all the machines around forced me to tidy up nicely, I think I'll move my bench around to that orange wall. This whole bench is just a temporary solution. It's made out of an old door. I need to post a correction. Last week, I mentioned that Ghent is in the Netherlands. I was quite quickly informed that it isn't. So I did a little research, and it turns out that Ghent is actually in a place called Flanders. Nico said something about French. Obviously this Flanders place is part of France because they speak French there. So yeah, so my apologies to all the people of Flanders. It won't happen again. Last week we had a little chat about towing aircraft. I remember back when I used to work for Lauder, Nicky Lauder used to keep his Learjet directly in the front of the hangar by the door. It was kind of a pain because it was kind of in the way when we wanted to do maintenance on the other aircraft, but you know, it was Nicky's Learjet. When you tow an aircraft, you really need 3 people, at least you did back then. Someone to drive the tractor, somebody to connect up the tow bar, and you wanted somebody up in the cockpit to release the brakes and reset the brakes once you were done. So anyway, one day we had to pick up a 737 and there was the shift leader myself, and I think a brand new guy who had only just joined the company. The two of us towed the aircraft. We disconnected it out there, drove into the hangar with the tractor. I guess we were expecting to have to make space in the hangar for the 737. So anyway, the team leader and I were talking to someone quite deep in the hangar, and it was actually the team leader who was the first to hear it, and he hears this. Someone yelling at the top of their voice, you know, "Hey, hey," and he looks up, and the 737, which we just parked, slowly rolling towards the hangar. He was quicker than me. He grabbed a chock, sprinted towards the door, and put a chock in front of the 737, which wasn't moving too fast, but it was moving directly towards Nikki's Learjet. And luckily he stopped it probably, I don't know, 10 metres or so before it ran into the Lear. Boy, pucker factor there, huh? So why did it happen? Well, when you tow, you normally start the APU, the little gas turbine, back in the tail of the aircraft, and use it to generate electrical power, so then you can run a hydraulic pump, so then you've got brakes. What you can also do is, if the plane hasn't been shut down for long, there's also a reserve brake accumulator, which is just a hydraulic pressure bottle with about 1500 psi of nitrogen pressing on it. So you'll get some number, I don't know, 3, 4, 5 brake applications before the brake accumulator goes flat. On this plane, obviously the brake accumulator was already empty, and the young guy we put on board to ride the brakes just didn't know it, and we didn't tell him. So that was definitely our mistake. Sorry, I forgot to introduce this. This is the collet closer. Basically, you've got the two pneumatic connectors. One of them pushes the piston to close the collets. The other one actuates the piston on the other side to open the collets. This is the collet draw tube. Just fits through there. And screws into the back of the piston. I haven't received a set of B32 collets yet. However, one of the really helpful viewers pointed out there was a good auction going on down near Belgrade in Serbia. So I bought that set of collets, which he linked, and I'm hoping they should arrive sometime late this week or early next week. I guess I should have done this before I took the big belt off. Fans of my torque multiplier selection, you know who you are. You're going to be super happy to see that this time I actually found a piece of pipe which is both galvanized and not rusty. Even in here there's a bunch of gold dust. I'll just mark this just to show where the nut was adjusted to. Not sure if that's going to be relevant or not, but it doesn't hurt. Further expanding on my torque multiplier collection is this lovely piece of rectangular tube. Okay, maybe with just a little bit of impact. Okay, that didn't take much. How's that for a nice precision nut? You can see that's been ground probably near perfectly flat. The headstock mounting is super easy. There's 2 screws on this side, 2 screws over the back. There are worm screws coming in from either end, pushing on the centering stud, and they're locked with those 2 worm screws. Next up, I'll remove the labyrinth seal cover. So then to pull the spindle, we just use a piece of threaded rod, pushing on the back of the spindle. Here at the front, our threaded rod comes through just to a crossbar, a couple of blocks of wood, crank on the nuts, and it should pull the spindle out. Let's see how that works. As this first bearing comes out, you can see that the V marking of the bearing has been placed at 12 o'clock. The front bearing has its V marking at the top, but the rear bearing had nothing, so I've just put a dash on it just to mark the alignment like they came out in. We have to wait for the new belt, which I've ordered, and can start thinking about how I'm going to lubricate these bearings. I could only lubricate 2 of them in situ, unless I go in with an injection needle to get to the front bearing of each pair. I'll have to have a think about that, but for now I'll just bag the whole spindle. My friend Jörg's had some issues with the sizing of the bores of his Schaublin's headstock. He got a 3-point micrometer and it's matching standard. And since it's here, we'll use it just to measure the headstock bores on my lathe and use that as a comparison. So measuring the aft bore, it's telling us minus 1/100th. Your front bearing journal was damaged because the rear bearing was installed an undersized bearing and was loose.
Measuring sticks like it's probably about 4 microns undersize or something.
So before we check the bearings, just checking the micrometer against Joe blocks. That micrometer was crap. We repeated this with a better micrometer, with the front bearing fit about 2 micron interference and the rear about a 4 micron interference. Plus minus 2 microns. Now I get to the point, what do I do about these bearings? I can see 4 options. Option 1, do nothing. Just wait for the belt to arrive, put it back in, don't even adjust the lubrication, and just run it. Pro, I don't screw anything up. The con, the grease has probably been in there 40 years. I don't really like that option. In option 2, wash the old grease out with a solvent, blow it all out with compressed air, and then use a syringe needle to inject grease back in, because that way I can get down not only to the uppermost bearing but also to the bearing below it, the one I can't access from the other side. Advantage, I don't screw up the shaft, I don't screw up the bearing preload or anything, and I get some fresh lubricant in there. I've got some Kluber MBU 15. The downside of that, of course, is it's not the ideal way to lubricate a bearing. I've got the issue of having old grease, which may contaminate the new if I don't get it all out. Plus, I won't be able to get the grease perfectly distributed. And I have seen the video from, can't think of his name. You know the one I'm talking about greasing precision spindle bearings. So I won't be able to do that. However, I've got all the time in the world, so there's nothing to stop me just doing a much, much slower run and lots of short, slowly increasing speed runs to let the bearings push their own oil out without overheating them. That's probably for me the preferable option. Option 3, I make up pullers, pull these bearings, lubricate them and reinstall them. The Pro, that's the proper way, I guess. Unfortunately, there's no real instruction in the maintenance manual of how to pull these bearings. Looking at the cutaway, it looks like it's best to make a close-fitting 2 half-shell style puller, which goes over here and clamps together and acts underneath the pulley wheel here. The reason for that being, the slinger ring's quite thin, and if you look, it only barely touches the inner ring, so you wouldn't want to put too much pressure on that. The forward bearing, the only way to get pressure on the inner ring looks to be through the labyrinth seal here. Now this labyrinth seal is cast iron. It's got to have some quite sharp cornered features to it. I'd be quite concerned about the strength of that and using that as a puller worries me. The last option would be pull these bearings off and just replace them straight away with new ones. Don't like that idea because P4 being the ISO equivalent to the American ABEX 9, a UM bearing, so it's a medium preload. A set of these 4 bearings is probably going to be at least 600 if not 900 euros. And there's no reason to believe these ones are damaged. The run out I saw when I tested the spindle looked great, so I'd prefer not to spend that money. So there we have it, 4 options. Do nothing, lube in situ, remove and lube, replace. I tend to number 2 for the reasons given. I'd appreciate your opinions. Please add your comments down in the comments section about it. What would you choose? Next up, I'll remove the Z ball screw. Damn, I hate cleaning up. This is too small. This is the 25 to 28. This is too big. It's the 40-42. It must be like the 32 to 35 millimeter that I need. And I know I own one because I've used it. But since moving everything around and cleaning up, I can't for the life of me find it anywhere. Oh, hear that? Got thunder. Listen to this. It's not supposed to be snowing anymore. Spring's here.
The very next evening.
Yesterday we pulled the spindle using a puller made out of this junk. I mean, it got the job done. So first Jörg pulled this spindle and I also pulled mine with this. But, you know, it's really just a collection of things that don't fit so well. So you really need 3 hands to hold blocks and stuff to get it to work. I kind of got an itch to make something. Let's make a little puller. Still going to be a junkyard special, but I'll make it to actually fit the job. I've got some M16 threaded rod that's going to be the main puller. This is going to be the crossbar. I'll shorten that up. This can be the offsets. I'll weld it together and I'll make a spacer that can go on either end of the spindle that actually fits. Oscar from On Time Machining took a bit of an unnatural interest in my little vise here. This was my apprenticeship project. We had to make this in the Air Force. They gave us bits of steel, blunt files, worn out hacksaws and ruined drills. And we had to file this and make this to within 1/1000 of an inch. Took some photos and sent them to Oscar with a few dimensions. He modelled the whole thing and sent me back dimension drawings. So if anyone's interested, I'll put a link down in the comments section. I'm not quite sure why anyone would want to spend 3 months of their life repeating an apprenticeship process, but if you want to, go for it. I don't weld that often, but when I do, I really like it. So instead of just doing a few little bits of weld, I tend to weld all over everywhere just because it's fun. As usual, my prettiest welds are the ones at the back which no one will see. Now that I've put the bolly in the garage, I've got the problem that the electrical cord's too short, so I need to switch that over for the cord which came with the Schaublin, which is longer. Pretty simple electrics on a machine of this age. Man, how weird is this? The earth wire inside this machine is red. Never seen that before. Never really want to see it again either. Alright, with that wired up, let's just turn it on and see if I've got the polarity correct. And of course I didn't. When you turn forward, it goes backwards. There was also a comment here which was, I guess, directed to Nico. And I got an answer from Nico. Honey, could you read this?
It is a machining channel, not an immigrant fitness series. Up and down and up and down. You two at the back, yeah, the Kiwi and the Pizzaiolo, move your fat ass.
Another piece of scrap. I'll need the other chuck for this. So I need a 15-degree taper, because that's what the B32 collets have, so that's the spindle nose. So here's how our spindle puller works. First the conical bushing goes in. Spindle gets offered up. The aft centering ring goes in. The bridge. And then we can crank on the nut to pull the spindle in. To remove the spindle, it's just the same the other way around. This bridge goes on the front and we pull against this back surface. Well, I think that's it for this week. If you enjoy this kind of content, then smash that like button and maybe send a link to somebody else who might like it. Thanks for watching.